Now we just need to go down to our draw structure and update this part as well. Instead of calling to a single one or each one, we have to do it through a loop, or at least the easiest way is to do it through a loop. So I'll copy this, come down here, paste, and the same thing's going to happen. For as many balls as we have, we're going to loop through, but here we need to change this line and this line, right? So what we're going to do is first we're going to say that we have to get the ball, or the current ball, right? We have to take the ball out of the bag, right, so that we can do something to it, which is going to be to call to the main update method. Okay, so I can get rid of these three lines here. All right, so how do we get the current ball? Well, we have to go back into the sports bag. We have to reach our hand into the sports bag and grab it. All right, so what we're going to say is that we're going to have a temporary variable of ball type called _b, and that's going to be equal to sportsbag.get, right? And we added an object to the sports bag, and we can get an object based on the index that it has associated with it within the array list. So we're going to say get I, close parentheses and semicolon. All right, so we've gotten the ball out of the sports bag, and now we can say that _b dot update, open and close parentheses, and we're ready to go. All right. So we don't have to change anything about our class because we're using the class right now as is, and we're just now creating many more versions of that class as objects, and then using the array list as a way to kind of manage all of those objects. So let's go ahead and hit play, and now we have an error, right? And this down here in the console window, it says cannot convert from object to a ball type. Right? It says this is the name of the sketch dot ball. That's this class type. So we said before that array lists don't have any kind of type information stored with it. It's just generically an object. So whenever we go to grab the ball out of the bag and store it in this variable called _b, we have to remind processing what we're getting, right? What type of object it is so that it goes well with the variable that we've declared here. So what we're going to do is kind of special bit of syntax called casting. So we're going to use parentheses to make sure that what comes out of here is understood as a ball. So you just put inside parentheses the same class type as here, and it will cast or ensure that this object is specifically a ball type, and then we can use it to update. All right, so now we have 20 balls bouncing around the screen, and they're kind of doing this in unison because all of the properties are consistent with it within the collection, right? Each one of them has the same starting speed, the same kind of drag forces, etc. So in this way, they're all exact duplicates of each other. The only thing that's different among them is where they initially start. Right? We kind of put them along using this I times 30 expression, put them along the x direction of our display window. Well, that's great, but that's not all that interesting, right? Let's see if we can't use the power of classes and create objects that have varying properties so we can understand them as different from each other, but still kind of inheriting the properties of our generic class ball. So the way to do that is that we're going to modify the class at this point. If we go to ball and we go to the constructor, instead of just only taking the position, anything that we want to change, we need to update or include here so that whenever we're constructing a ball object, that it has that functionality as a part of it so that it can create kind of new version of it that's different, right? So instead of just x and y, let's go ahead and add in y speed. So I'm going to say float _y speed. Now that's going to be added to the constructor. And I'm using this underscore as a way to just create a temporary variable that has the same, almost the same name, but is different, so that I can just say that the y speed will be redefined by what's coming in from the constructor. Okay. So now that I have this as an option with my constructor method, I need to go ahead and make sure that I adjust the instantiation that I'm using here by adding a third value. Right? So I'll do comma after height over 2. And let's use a random value between negative 0.2 and 0.2, which, okay, sorry, between 2.0, negative 2.0 and 2.0. Okay, so we had before defined y speed as 2, so let's use a random value between these two extents to define the initial y speed. We hit save, run. So now we're getting a different initial starting speed for each of our ball instantiated objects. All right, and we can make this more interesting, right? You can change the values here, and they'll have more diversity in terms of how fast they're falling, right? So let's take a second and take an opportunity to experiment with this. Add in one more argument to your ball constructor and use that so you can show more difference within your collection of balls. So we'll take a minute and let you go ahead and experiment with that. All right, so let's see some of the suggestions that you offered in terms of how we might modify the constructor. Well, an easy one to implement that is pretty fun would be using the radius, right? So if we take the radius and we include that as another variable, that would be a part of our constructor. So underscore rad equals underscore rad. All right, and then we can go back to our instantiation of our objects and also add maybe a random value between 20, which was our value we were using before, and 40. So now we have balls of different size that are bouncing across the screen, and they're falling at different rates. All right, and we're storing each one of those in an array list. All right, great. So if you have any questions, go ahead and drop them into the question window, and we'll address them as a group before we move on to the next exercise. One question we got was, why does it look like they're repeating in terms of their the rate at which they're falling? Well, that has to do with this little method here that's a part of processing called random. It's kind of pseudo-random, and a lot of times it's not very good at giving a very diverse collection of elements. It will seem as though it's repeating. So there's some other methods you can use that include noise, etc., that might give you a more kind of differentiated collection of values for your input here. But we'll just keep it random for simplicity's sake for right now. Okay, well, it doesn't look like there's any other questions, so let's go ahead and move on to the next exercise. And we left off where we were talking about array lists.